Okay, this one's a bit of a doozy, and I'll try not to make errors that I end up then correcting, but all right. So now we're going to optimize a geometry situation. A geometry student wants to draw a rectangle inscribed in the ellipse x squared plus 4y squared is equal to 36. So remember that ellipse is centered about the origin. What is the area of the largest rectangle? There's a lot of different ways that you can draw an ellipse, right? I mean, that's a specific ellipse, so that draws itself. But what is the area of the largest rectangle that the student can draw? So this is what we know. We know that that's what the ellipse is. That's essentially it. But because I know I don't want to deal with x's and y's, I'm going to take the time to figure out what y equals. So to get y by itself, I'm first going to subtract x squared and then divide everything by 4, which is what I did there. I subtracted x squared from both sides. Now I'm going to divide everything by 4. But this is y squared, so I'm going to take the square root of both sides. Remember, the square root of 4 you can simplify. So that ends up being, do you take the square root of y squared is y, and I'm going to rewrite it to the 1/2 power, and that's now going to be over 2, right? So here's the diagram of the situation. If it's centered about the origin, notice what we have. On either side of the y-axis, part of the length of that rectangle are 2x's. So the length is equal to 2x, and then look at the width. You've got the x-axis above and below. The width is 2y. Ooh, but now we know what y is. So the formula that you find the area of a rectangle is length times width, but we know what our length is. Our length is 2x, and we know what our width is. Our width is 2y, but we also know we now have a value for y. So it's this 2 times all of this stuff with a 2 in the denominator, then the 2 times and the 2 divide cancel, and what you are left with is area is equal to 2x times essentially the square root of 36 minus x squared, except for I wrote it as the 1/2 power. Well, look at now what you've got. You've got a product rule. You've got an f times g. So when you find the derivative of this, you use the product rule. F times g prime plus g times f prime. So first thing that I did after I rewrote this stuff, here's our f prime, here's our g prime. And for those of you who are not yet confident with your skills, you'll get there on rational. Remember, this is the chain rule. So the 1/2 comes down in front, which is what I did right here. I brought that 1/2 exponent in front. And then when you subtract 1, 1/2 subtract 1 is negative 1/2. Well, then this whole expression, stuff to the negative 1/2, will get moved to the denominator in just a second. And then you have to multiply by the derivative of that stuff. Derivative of 36 is 0. The derivative of negative x squared is negative 2x. And now look at, when you multiply negative 2x times 1/2, the 2's cancel, just leaving negative x. So now what do we have? We have negative x over, and then all of this stuff, because it's to the negative 1/2 power, we brought it to the denominator, and now it's the positive 1/2 power. So this is our g prime. All right. So when you set it up, and then I'm going to move to the next screen, the derivative of the area is f times g prime, and I'm going to just leave it in stuff to the 1/2 power, plus g, which is stuff to the positive 1/2 power, times f prime, which is 2. And I think that's what I did over here. I just went ahead and filled in the stuff. I wonder if I can, no, I can't. All right, so now we're going to simplify that. 2x times negative x is negative 2x squared. So that's this fraction. And this, the only thing that changes is the 2 comes around in front. But now we've got this fraction over here with the denominator. Well, we're going to have to multiply this one top and bottom by that stuff to the 1/2 power. That's essentially saying this square root times this square root. So remember, whenever you multiply a root times a root, the radical goes away and the number stays. So when we simplify this, the radicals go away and it will leave this thing to the 1st power. So I think that's what I did here. Well, I did, but let me go ahead and simplify it one more time. This is now going to share the same denominator. We have a negative 2x squared plus, now this is just 2 times in parentheses 36 minus x squared, because the 1/2, remember when you multiply powers of the same base, you add the exponent, so that's just that to the 1st power, and now you can do the distributive, which is what I did. So 2 times 36 is 72. 2 times negative x squared is negative 2x squared. So now we can add the negative 2x squared and the negative 2x squared is negative 4x squared plus 72. Now notice these both have a 4 in common, but I'm going to factor out a negative 4. And notice I've set it equal to 0. Well, right there, I could fill that in, 36 subtract x squared, but I don't even care because look it, we don't want this denominator, so when we multiply both sides by that stuff to the 1/2 power, stuff to the 1/2 times 0 is still 0, and now we all we have left is that lovely numerator, and now I factored out a negative 4, leaving negative 4x squared divide negative 4 is just positive x squared. 72 divide negative 4 leaves negative 18. And now you just set x, here, let me change the color. X squared subtract 18 equal to 0. So we'll add 18 to both sides. When you take the square root, rewrite 18 as 9 times 2. So x equals 3 root 2. And normally for a quadratic, we would put positive or negative. But because we're talking about length, it's just 3 root 2. So each of these x's right there are 3 root 2. So when you do 2 of them, that entire length will be 6 root 2. All right, so let me put over here someplace really obvious. X is equal to 3 root 2. Well, now, what did we say? Cover all that up. Well, what did we say y equaled? Y equaled that stuff to the 1/2 divide 2. Well, that stuff was 36 minus x squared. Well, x is 3 root 2. So now we have to do the arduous task of, I'm going to make this a lot bigger. Well, 1/2 power, I'm going to turn this back to square root. So let's see, this is 36, subtract this stuff squared. Well, 3 squared is 9, so 3 root 2 squared. 3 squared is 9, root 2 squared is 2, 9 times 2 is 18. Well, now we have 36 subtract 18, which is just 18. Well, the square root of 18 is 9 times 2. So now we have y is equal to the square root of 9 is 3 root 2 over 2. So remember our original area formula was 2x times 2y. Here's our x, here's our y. So 2 times 3 root 2 times 2 times the y, which is 3 root 2 over 2. And yes, I realize those 2's cancel, but whether we can't, if you remember that or not, let's just do it this way. Let's do it just straight across the numerator. 2 times 3 is 6. 2 times 3 is 6. 6 times 6 is 36. Root 2 times root 2 is 2. Well, 36 times 2 is 72. But now we have this divide 2. So the area will be 36 units squared. Ta-da! We got through it. That's it for the geometry, the maximizing a rectangle inscribed into an ellipse.